Maximum length of a USB cable? I want to use a very long USB cable to place a webcam in a different room. The maximum length that I found was 5 meters. What is the maximum length of a USB cable? What is the maximum length achievable when using USB extension cables?
Five meters is the maximum USB cable. You can get further by connecting USB hubs serially, maximum of 5 hubs chained this way. You can't just use USB extension cables due to timing issues. From the USB fact. Q1. How long of a cable can I use to connect my device? A1. In practice, the USB specification limits the length of a cable between full-speed devices to 5 meters, a little under 16 feet 5 inches. For a low-speed device the limit is 3 meters, 9 feet 10 inches. Q2. Why can't I use a cable longer than 3 or 5 meters? A2. USB's electrical design doesn't allow it. When USB was designed, a decision was made to handle the propagation of electromagnetic fields on USB data lines in a way that limited the maximum length of a USB cable to something in the range of 4 meters. This method has a number of advantages and, since USB is intended for a desktop environment, the range limitations were deemed acceptable. If you're familiar with transmission line theory and want more detail on this topic, take a look at the USB signals section of the developer's spec. Q3. How far away from a PC can I put a USB device? A3. With a maximum of 5 hubs connected with 5 meters cables and a 5 meters cable going to your full-speed device, this will give you 30 meters of cable. See section July 1, 2019 for details. With a low-speed device, you will be able to get a range up to 27 meters, depending on how long the device's cable is. With a straightforward cable route, you will probably be able to reach out 25 meters or so from the PC. Q4. I need to put a USB device X distance from my PC. What do I do? A4. If X is less than 25 meters or so, see previous question, buy a bunch of hubs and connect them serially with 5 meters cables. If you need to go farther than that, put another PC, or maybe a laptop, out where you need the device to be and network it with the first PC using something that's intended to be a long-range connection, such as Ethernet or RS-485. If you need to use nothing but USB, consider using USB-based Ethernet adapters to hook the pieces together.
All answers are incorrect if op meant the link operating at high-speed USB 2.0 communication speed, 480 and NBSP, bit/s. The length of a USB communication link is limited by the USB architecture of having 5 hubs in a link. The USB protocol requires that USB devices send back handshake packets as ACK, NOC, NRD, etc. These responses must come back to host within a specified timeout, which is set to 1.7 and NBSP, microsecond. The host controller hardware would set a flag/interrupt if the response is not received in time after 1, 2, 3 attempts, which would mean the link failure. Now, what was the basis for this 1.7 and NBSP, microsecond limitation? It is based on a worst-case round trip of handshake packets. All is explained in USB 2.0 specifications, section 7.1.19.2. There are 3 factors. Physical signal integrity over a twisted pair differential for a realistically manufacturable cables, impedance matching, cable uniformity, signal loss. This came out as 5 and NBSP, M cable length limit per segment. A 5 and NBSP, M cable has an estimated one-way propagation delay of 26 and NBSP, NS per USB specifications. All 6 cables will have the round-trip delay of about 300 NBSP, NS. Digital signal propagation delay along the hub's repeater path, which is limited to by suggested architecture to 40 HS bit times, which is about 80 in NBSP, NS per hub one way. 5 hubs will have the round-trip delay of about 800 in NBSP, NS. A USB device is allowed to respond in 192-bit times, which is 400 NBSP, NS. So, total response time is 1500 NBSP, NS. The specification allows some slack, and extends the time out to 1700 NBSP, NS. Therefore, the limit for media propagation time is 1700 NBSP, NS, 400 NBSP, NS equals 1300 NBSP, NS, or 650 NBSP, NS one way. If you can manufacture a cable that has such a low loss over 650 NBSP, NS of wave propagation that it can deliver an open signal meeting USB far end template, a host with a single USB device can work with it. Taking 26 NBSP, NS per 5 NBSP, M, it comes down to 125 NBSP, M of cable. This is the maximum theoretical limit. I'd love to see if this kind of cable can be made. Personally, I had a good no-error link with 40 NBSP, foot, 12 NBSP, M, cable made of CAT and NBSP, 5E. But it depends on quality/sensitivity of receivers on both ends of a link. Addition, the above answer is valid only for overall USB-HS communication protocol. However, there is another functional limitation on the maximum cable length in USB. It is related to high-speed disconnect function. The HS disconnect in USB is based on an idea that a disconnected cable would reflect the signal back, so the reflection adds up to the driven voltage leading to doubling of signal amplitude at the transmitter. As designed, the HS host sends microframe markers, called SOF, every 125 S. For the purpose of cable disconnect detection, the SOF packet has an elongated end of packet, 83 ns long, normal EIP is 16.6 ns long. If the USB cable is disconnected at host port, no problem. But if a device, with its termination, is disconnected at far end of a long cable, the reflection must come back within 83 ns, the amplitude will double up, and a special comparator in the PHY receiver will register the HS disconnect condition. This sets the cable limit of having 41.5 ns one-way propagation delay. Assuming 6 inches propagation speed per 1 ns, this requires the cable to be less than 250 inches long, or about 6.5 meters long. This limitation takes place only if you want to sense a clean and fast disconnect. With longer cable, the host port will be eventually disabled due to protocol error, so not much problem at the end.
According to USB specifications, cables longer than 5 meters would cause a too large signal propagation delay to work. But I've managed to build a 10 and NBSP, M/30 and NBSP, foot passive USB 2.0 extension cable that worked just fine. All I did was to use an FTP CAT and NBSP, 5E OG 24100 and NBSP, ohm cable with one twisted pair for data, D+ and D. I used the green pair, and the other 3 twisted pairs for power, V+ and V, in parallel solid to solid and stripe to stripe. I've had no problem using any USB device over this cable. A quick test with a USB storage device measured 292 MB/s, same as when connected without the extension cable.
If you wanted to support the channel, please consider subscribing.